this why and making joyful or making learning joyful could have been done for any subject. What made you pick coding and math specifically?
So coding is an interesting one, and I think it's the perfect tool to solve many of the problems that exist in education. The first one is that it is just fun. Exactly as I said, like what's important is inspiring kids to see the joy in learning in of itself. And if you can make the process of learning fun, the rest will take care of itself. And coding is incredibly fun because you can literally build whatever you want or whatever you can imagine. You want to build a game? Cool. You want to build a robot to clean your house? I mean, we might be living in a simulation, which is coded. Like, so you and I might be some Strive student in 5 years' time that's like, I wonder what this coder does. So it is incredibly fun and rewarding to build stuff. And so it makes the process of education fun. That's the first one. The next one is that it then has instant feedback loops. So one of the issues with every other subject, the way it's done in pen and paper, for example, with math, is that you would write down your answers to a test or write down your answers to a homework, and you would get your answers a week later from your teacher, who maybe marked them, and you can't remember what you learned. You can't remember what you were thinking at the time. The feedback loop was a week for you to have that learning. Whereas with coding, it is instantaneous. You make one change to a number, you add one line of code, and you can instantly see how that affects the output. You can instantly see if you are right or wrong. And that effect is incredibly addictive because it then all of a sudden means you make progress much quicker and you start learning much faster. And that just becomes joyful in of itself. The last reason why coding is a really important ingredient or aspect here is that it is a more accurate representation of how we actually learn. So the model of how we learn is a little bit broken. The current model we think of how people consume information or learn new things is kind of like filling up a glass of water. So you picture a teacher as being a jug full of water with all the information, and a student being a glass, and the teacher needs to come and pour the water into the glass of the student. But that isn't what happens. Exactly as I said previously, we do not learn by passively consuming information. The way we learn is by actively constructing information and by building things. There's a theory or a philosophy of pedagogy, of learning science that was popularized all the way back in the 1970s. And we're only like dealing with this now. But a guy called Semir Papper, I'm probably butchering his name. But regardless, what he talked about was this model of learning through experience, was this model of learning through taking the models that you have of the world and putting them out there. And in the process of putting out your model of the world, how you think about the world, how things should behave, you see where your assumptions are, you see where you're right and where you're wrong. And that is exactly what coding does. Coding is the process of taking what you think about a system. Like if you want to make let's take an example of how does a ball bounce? Or how does gravity work? If I throw a ball up in the air, if I am able to construct the system that simulates how a ball gets thrown in the air and falls back down, I need to address every single one of my assumptions of physics and math involved in that system. Like, how fast does it move when it starts going? How does the speed start changing as it gets higher and higher? And why does it start coming down and go faster and faster and faster? Each one of those requires you to lay out your assumptions bare. And in the process of laying out those assumptions, you see where you don't understand things. You see where things are not clear. And that's why coding is going to become such a powerful tool, not only in math education or science education, but any form of education, because it allows you to perfectly illustrate or express your understanding of a situation. It's quite a technical explanation. The last, maybe non-technical explanation I'll give is there's a famous learning technique called the Feynman technique, which says if you really understand something, you should be able to explain it to a 5-year-old. And a computer is the silliest 5-year-old you have ever spoken to in your entire life. Right? Like a 5-year-old, you can maybe tell them like, hey, go get me that ball and put it over here. But a computer, you need to say, okay, take 3 steps to the right, then go 4 steps forward. Do a forward flip over the couch so you don't fall. Pick up the ball with your right hand, come back 4 steps. Like, all of those steps need to be perfectly illustrated. And so in order to do that, you need to fully understand the system that you're trying to express.